Hey, hey YouTube, finally, this is the last video. Today we'll talk about addressing some important topics, which are scalability, availability, and data integrity. Basically, we will know how Instagram stays fast online and reliable at a global scale. So Instagram serves over billions of users, over billion users, not billions. Sharing photos, watching stories, liking posts. Yeah, it's a lot of things. Every second of the day, but how does it stay pretty fast online and reliable no matter what happens? In system design, we call this the SAD trio. What is a SAD trio? It's basically scalability, availability, and durability. And in this video, we will break down exactly how Instagram tackles each one. So first, let's start with the scalability. I need my pen here. Okay, so we start with the S, which is scalability. So scalability means the system can handle more users, more posts, and more traffic without slowing down at all. First, we will talk about scaling, horizontally scaling. So, which is scale out. So, Instagram will run a distributed database, like all the databases that you see here. We will run distributed databases like Cassandra or DynamoDB, which are data that can spread across multiple nodes. So not just scale vertically, and each microservice, like a post service, for example, and maybe a feed service as well, will runs multiple instances as well behind the load balancer. So each service has more than one instance. So by this, we improve the scalability. We add horizontal scaling. Number two, we use the sharding strategy, like to avoid database bottlenecks. Instagram shards large data sets like user data, posts, and follows. So all of that will be sharded, which will basically will be copied in multiple nodes. Also, there is important things to know that to handle scalability was using microservices and Kafka. We're using a lot of message queues here. We can add even more message queues to the system. I guess it will be still a better idea. So the app is broken into multiple microservices like the user service, engagement service, search service, feed service, and the post service. And they communicate with via Kafka or RabbitMQ, so each service scales independently. An example for that, I guess it's the famous example: the post service sends an event to the message queue, and the feed service will pick the event from the message queue, and and do whatever it wants with it. So next we will talk about the availability. So in the availability, we basically want to stay 24/7. So Instagram is global. People post in Tokyo when it's midnight in New York. So availability is quite crucial and critical, and the system must not go down at any circumstances. So we will use redundancy and multi-regional replication for that. Like Instagram uses replicated databases across regions. So we again replicate these databases, but in multiple regions, not only in one region. For example, maybe the Postgres SQL or which is the user DB, or maybe the Cassandra cluster span multiple data centers across the globe. Also, application services, user service, engagement service, search service will be deployed across multiple availability zones on the globe. If one fails, the traffic will be directed to the other instance, and this is. Also, we need to talk about failover mechanisms. Like database maybe have automatic failover mechanism like leader follower setups in PostgreSQL. So Instagram will use critical breakers. So if one service fail, the app will gracefully decrease rather than crashing. Okay, so we will go with the D. The D is durability, like basically, which to never lose your data. We'll do this if you look at the blob storage that we're using. Instagram will store the photo videos in cloud storage like Amazon S3 or Google Cloud Storage. These services replicate data across multiple zones, making sure it's never lost. Also, we will use data backups and replication, like for all metadata here that we are using, like comments, and also and also here's anything like and comments as well. Instagram uses multi-region replication, and we have backup strategy. So we have a regular snapshots, point-in-point recovery, and disaster recovery testing. Also, there is a write-ahead logging and event sourcing. Like database like Postgres use write-ahead logging, meaning changes are logged before committing. Instagram also uses event sourcing, storing every action as an event. So even if something breaks, the system can replay events and rebuild the correct states. Okay, so let's make a small recap here. So in terms of the SAT, let's start with the S, which is the scalability. So we sharding, load balancers, microservices, and Kafka. In terms of the A, which is the availability, we use multi availability zones deployments, we use failover mechanism, and we use circuit breakers. In the terms of the durability, we use S3, replicate databases, and we use event source and backups. So yeah, that's it. That's the end of the series, and yeah, I hope you like this series, guys. Yeah, it was a fun for me. I hope it was fun for you too, and see you in future series.